This next section, we will give you more tools and testing to use with IQ Wi-Fi 6. The goal with this section is to help you feel more confident with placing an agent and understand some detailed information on the web UI. The easiest way to troubleshoot IQ Wi-Fi 6 is from the LED feedback. There are 4 LEDs on every IQ Wi-Fi 6, but only 3 of them are currently operational. The power LED is on the bottom center of every IQ Wi-Fi 6. And will be one of 2 colors, red or green. Green is a good color, and it means that we're doing one of 2 things. We're either booting up with no problems, or if solid green, we are good to go. Red will mean a critical error, but when flashing indicates a factory reset. The WAN status LED gives an indication on the agents that you have connectivity between agents and the mesh network. If solid green, you are good to go, and the link is strong. If a slow flash, the agent link is medium and probably okay. If the LED has a double blink, you should probably move to a better location or add an additional agent to help with the link quality. The LAN status LED is either on or off. Green means it is broadcasting and the SSID is ready to be connected. Let's talk just a minute about different frequencies and bands. Band frequencies, the difference between IQ Wi-Fi, the Gen 1 router, and IQ Wi-Fi 6 Gen 2. On this particular slide, you'll notice that we have 2 pie charts to help illustrate the 2 technologies. Each pie chart visibility is different in size, representing the amount of data that each of these technologies can transmit. Our Gen 1 router is an AC1200 device, and our Gen 2 router is an AX1800 device. AC1200 is a sum of all the bands on which the router emits Wi-Fi signal, not the real speed of the router. One key aspect of calculation that results in the AC or AX naming is the number of bands or frequencies on which the router emits the wireless signal. Our Wi-Fi mesh routers are dual band. Newer technologies support even tri-band. Most mesh routers are dual band, meaning that they have 2 frequencies that they use to auto-connect between agents. Using our IQ Wi-Fi as an example, it has 2 bands. Each of them has its own maximum theoretical bandwidth. The first band and the slowest is the 2.4 gigahertz wireless band. It has a maximum shared theoretical bandwidth of 300 megabytes per second. The second band and fastest is the 5 gigahertz wireless band. It has a maximum theoretical band of 900 megabits per second. Therefore, AC1200 is not the maximum bandwidth that you can get with this router. You get only one wireless band or frequency, but not the sum of all the available wireless bands or frequencies. The maximum speed that you could get is that of the fastest band, in this case 900 megabytes per second, which we are only going to get in a laboratory. All manufacturers of networking equipment do not use real-life measuring environments. They do their measurements in specialized labs so that they can claim the maximum possible speed. These tests would be like the open air tests that we use for Power G or even legacy SRF tests. But I would also suggest that they're even more controlled even than those tests. Very much the same idea we have going on here with AC1200. AX1800 is the sum of both 2.4 and 5 gigahertz. AX1800 means 574 megabit speeds on 2.4 plus an additional 1201 megabits at 5 gigahertz. Keep that in mind that these numbers again only are achievable in perfect conditions. One thing to hang our hat on with Gen 2 is the technology that we have. Even with these technologies, it's important to understand agent placement. RSSI and SNR can be simple if you can understand them. A good rule of thumb is to place an agent within about negative 65 dBms, if possible. This will keep you in a good or an excellent range of wireless connectivity. Most of these units will be deployed and have no problems. But in the event that you have an issue, we have some additional bits of information that can help you troubleshoot. If you have problems and need to rely on the web UI and dig a little deeper, open up a web browser and type the gateway address of 192.168.105.1 using the default username as admin and the password that's printed on the bottom of the controller. Log in to your IQ Wi-Fi 6 network. Once logged in, on the main page you can scroll down near the bottom and see a list of agents. The two columns to pay close attention to are the 5G RX and the 5G TX. For optimal connectivity, we want these numbers to be above 300. A quick painless area to check is also the channel. These units ship on auto channel selection. Most of the time, auto channel selection is going to work very well, but in the event that you need to do some additional troubleshooting, select channel 104. Channel 104 seems to be a bit louder than the rest and may be a better option for channel selection. Note, if changing the channel, once you touch save, the router will reboot. In these last slides, I wanted to spend just a little bit of time explaining some of the additional support that we have. We actually have a few different Facebook groups, and if you are not already participating, I would recommend getting yourself acquainted to these groups. Most of our TAMs and support agents actually hang out there to help out. The main Facebook group is the Qualsys and Alarm.com installer group. We've gotten some great feedback here, and I definitely recommend it. Additional self-help. For more self-help, scan the QR code here to find the latest versions of the Quick Start Guide, spec sheets, and installation guide. These guides are always hosted on our dealer portal or customer portal at qualsys.com or dealers.qualsys.com. Thank you for taking the time to review IQ Wi-Fi 6. We definitely take pride in our work and look forward to your feedback as we continue to build better products and solutions for our customers.